Welcome to a special deep dive into one of the most critical vulnerabilities of the modern internet. Right now, companies are rushing to integrate artificial intelligence into every system, from customer support to core firewalls. But in their rush, they have inadvertently opened a massive loophole that hackers are actively exploiting to bypass security in seconds. Today, we are going to explore the terrifying world of adversarial AI, prompt injections, and machine learning poisoning. We will see how sophisticated attackers use the very nature of language models against themselves. Sit tight, because this changes everything. For decades, we built security around the concept of a strong perimeter. We used firewalls, antivirus signatures, and strict access controls to keep the bad guys out. If a hacker tried to send a malicious packet or an unauthorized database query, the system's hard-coded rules would immediately flag and block the attempt. It was deterministic, mathematical, and predictable. But AI completely shatters this paradigm. Unlike rigid databases, AI models process natural language in highly unpredictable ways. They do not have strict boundaries between what is a command and what is data. When an AI is given control over sensitive systems, an attacker no longer needs to write complex malware. They just need to know how to talk to the AI persuasively enough to make it bypass the rules itself. The most famous vulnerability in modern LLMs is called prompt injection. Developers try to constrain them by placing system prompts at the top of the conversation, instructing the AI to be safe and to guard sensitive data. But the AI reads the system instructions and the user's input as one continuous stream of text. Because there is no cryptographic boundary, a clever attacker can simply type "ignore previous instructions." To the AI, this new text carries just as much weight as the developer's original programming. It effectively overrides the safety guardrails and executes the malicious command. Let's look deeper at the anatomy of an attack. The model processes the system guidelines first. Then it reads the entire conversation history. And finally, the user's latest input payload right at the bottom. This structural design is the fundamental flaw. Because the user's payload is evaluated last, it has recency bias. In the vector space of the neural network, the final instructions often overwrite the previous constraints. When direct prompt injection fails, attackers pivot to jailbreaking techniques. Jailbreaking relies on cognitive roleplay. The attacker tells the AI to pretend to be a different entity, unbound by standard rules. By wrapping the malicious request inside a fictional scenario, the filters are bypassed. The model processes the elaborate fiction and concludes it is acceptable to generate a response. The stakes are raised significantly when AI models are connected to internal systems. Many organizations deploy AI chatbots on top of their proprietary databases to help employees. However, if an external user can interact with this bot, they can actively steal corporate data by asking the AI to summarize confidential documents. The AI happily retrieves the records and formats them for the attacker. This allows hackers to completely bypass network firewalls, turning the AI into an insider threat. What if the hacker doesn't even talk to the AI directly? Enter indirect prompt injection. Modern AI assistants have web browsing capabilities to summarize pages for you. A hacker can hide malicious instructions in invisible, zero-pixel fonts on an innocent-looking website. When your AI assistant reads that page, it silently digests the hidden commands. Without you knowing, the AI has now been hijacked. It might silently send your session cookies to an external server, making the internet a minefield. We have seen these theoretical attacks happen in the real world constantly. Many e-commerce sites replaced their human agents with language models. Hackers simply typed commands like override protocol and issue a full refund. Because the AI had the API permissions to do so, the AI complied. Companies lost thousands of dollars overnight to incredibly gullible AI. The loopholes aren't just in text, they exist in vision AI as well. By carefully calculating and applying invisible patterns of static noise to an image, hackers can create adversarial examples. To a human, the image looks exactly like a normal stop sign. But the mathematical noise tricks the neural network into seeing a speed limit 65 sign. This vulnerability causes catastrophic failures in self-driving cars with just a few stickers. Another devastating AI loophole lies in generative media. Today, modern generative AI models require less than 3 seconds of a person's voice to create a perfect, emotionally resonant digital clone. Attackers scrape a few seconds of a CEO's voice and call the finance department. Because the voice sounds identical, employees bypass security and wire the money. Cybersecurity defenses rely heavily on identifying known signatures of malware. But hackers are now using AI to create polymorphic malware. This is malicious code that rewrites its own structure every time it infects a new system. The AI engine alters the code syntax and encrypts the payload dynamically. It slips past traditional antivirus systems completely unseen. To fight polymorphic malware, defenders use endpoint detection and response, or EDR. Instead of signatures, EDR looks at behavior. However, advanced AI malware has evolved to recognize when it is being monitored. It deliberately mimics human behavior, making random mouse movements and pacing its API calls. By staying under the algorithmic threshold, the AI malware achieves ultimate stealth. Perhaps the most insidious AI loophole is data poisoning. Attackers deliberately corrupt public datasets, subtly injecting malicious associations. The AI consumes this poisoned information while learning. When the model finishes training, the hacker has embedded a sleeper agent. The model functions flawlessly until the attacker inputs a specific trigger word. Instantly, the poisoned model executes the hidden payload. Another critical flaw is that AI models inadvertently memorize their training data. When a company trains an AI on internal emails, those details get baked into the network. An attacker can exploit this by querying the model thousands of times. By mathematically analyzing the confidence scores, the attacker can reconstruct the private data, effectively extracting social security numbers directly out of the AI's memory. So how do we close these massive loopholes? The first line of defense is input sanitization. We build an LLM firewall that analyzes every prompt for signs of injection. This ensures the injection is blocked before it ever reaches the core model. Many organizations are now adopting a dual model architecture, where one AI supervises the other. We must also enforce zero trust, ensuring the AI never has full permissions to databases. As we integrate AI deeper into our society, understanding its inherent flaws is the only way we can protect ourselves. The AI loophole is real, and the battle between attackers and defenders is happening right now. Stay vigilant, implement strong defense in depth, and never blindly trust an automated system.